Alright, so in this video, we're going to be talking about the direction angles and direction cosines, okay? So first we need to kind of define these terms here, okay? Direction angles are the angles between the positive x, y, and z axis and a vector, okay? So you have three direction angles. One is the angle between the positive x-axis and a vector. The second is between the positive y-axis and a vector, and the third is between the positive z-axis and a vector. Okay, and I'm going to show you a visual of that if that's not really making too much sense to you. Okay, now to find the direction angles, okay, to find these angles that we're talking about here, we must first find the direction cosines. Okay, and I'm going to give you equations for that. All right, so here we finally have it. This took me forever to do, so be appreciative. Okay, so here is your direction angles. You have alpha, beta, and gamma. Okay, alpha is the angle between the positive x-axis and a vector. Your beta is your angle between the positive y-axis and a vector, and gamma is the angle between the positive z-axis and a vector. Okay, so you can even see that illustrated down here. Okay, we have alpha. We have our vectors in blue, and alpha is that angle between the positive x-axis right here and the vector. Okay, you can see beta and you can see gamma. Okay, doing exactly what's described here. All right, and here is your direction cosines. Okay, obviously to find these angles, you just take the inverse cosine of each side. Okay, so the direction cosines are kind of like an intermediate step. But sometimes you may just be asked for the direction cosines. Okay, so you don't even need to find the direction angles. All right, so if you have a vector a1, comma a2, comma a3, then cosine of alpha equals the x component over the magnitude of a. The cosine of beta equals the y component, the second component of your vector, over the magnitude of a, and cosine of gamma equals the z component, right? A3 over the magnitude of a. Okay, so we're just going to do a quick example here, and that'll be it. So we're asked to find the direction angles of the vector -2, 5, 3. Okay, so all we really need to do, you can see from our direction cosines, all we really need to do is find the magnitude of a, okay, of our vector. Okay, to do that, we use our distance formula, right? We're just going to plug in -2 squared plus, and I'll put a magnitude here, there, -2 squared plus 5 squared plus 3 squared. And that's going to be equal to a 4 plus 25 is 29 plus a 3 squared will be 38, rad 38. Okay, so now let's find our direction cosines. Okay, cosine of alpha is going to equal, well, a1 is -2. So we're going to put -2 over rad 38. Cosine of beta equals a 5 over rad 38. And cosine of gamma equals a 3 over rad 38. So now, just solving for the angle here, we have that alpha is equal to the inverse cosine of -2 over rad 38. We have that beta is equal to the inverse cosine of 5 over rad 38. And we have that gamma is equal to the inverse cosine of 3 over rad 38. And there you go. Okay, those are your direction angles. Okay, what are they representing? They're representing this. Okay, alpha, the distance or the angle between positive x-axis and your vector. Okay, the beta is the angle between the positive y-axis and the vector, and the gamma is the angle between the positive z-axis and your vector. Okay, so that is what we are finding here. All right, and that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.